You guys gonna take off? Okay. Okay, so what you could do is then just start working on the first few questions of that assignment. Okay, so systems of equations, this is a concept that really applies in physics. It's actually a time where I discovered when I taught physics last year that we could use systems of equations a lot. And from what I understand, you guys actually have done a little bit of this probably last year. The idea is something called multivariable algebra. You probably haven't heard it called that before, but if I give you a single variable algebra, we're solving for just x. Does that make sense? And that's what we've done so far. The problem is that most things in life, especially in like the chemistry, especially physics world, there's more than one variable. For example, you guys must have a little bit of experience with physics. You guys know how to calculate a velocity?
Yeah.
What's a velocity equal to? No, velocity is equal to the distance you travel divided by time. Do you guys know that? Yeah. Even if you didn't. The difference there between single variable and multivariable, I mean, you guys get the idea of single, one, multi, more than one. Most formulas that we work with in physics or chemistry or somewhere else, usually they involve more than one variable. Does that make sense? Let me see if I can diagram this here. Velocity is equal to distance over time. Therefore, there's not just x's, there's x's, y's, and z's. Does that make sense? Sometimes there's formulas, though, where there's really only like one variable. So far we've been working with this. Now my goal is what happens if we have to have distance and time, or I don't know, what else we use in chemistry? Degrees Celsius and grams. What happens when we have multiple different variables to work with? So that's where systems of equations comes in. Okay. Okay, here's the basic concept behind systems of equations. I'll even highlight this. You need one equation for each variable if you want to solve. So if you've got x, you can solve an equation with only x so long as you've got one equation. If you've got x and y, you need two equations. If you've got x's, y's, and z's, you need three equations. Does that make sense? So I think you guys have done this a little bit before last year. I think. It probably would have been one of the last things you did. Do you guys know the terms substitution and elimination? Sound familiar? Okay, well, I'll go over them if they don't. Okay. So you see how here we've got x's and y's, and here we've got x's and y's? In order to solve this system, I'm using my fingers, of equations, two variables means two equations. Okay. Rather than solving for just x, we have to solve for all of the unknown variables. So this makes it more challenging. You know how recently we've been solving for x, and maybe there's one answer for x, maybe there's two answers for x, maybe there isn't an answer for x. Well, now there's answers for x and for y. So there could be one answer for x and two answers for y. Or there could be two answers for x and two answers for y. Does that make sense? That's what takes this to the next level. So let me show you how to solve this. Maybe you've done this before. My favorite way to solve something like this is using something called substitution. Substitution basically involves try to solve one of your equations and get a variable by itself. And this one right here is actually already set up like that. See how x is by itself? X is supposed to be equal to 3 minus 2y. In substitution, what you do then is you take this little bit right here, and everywhere over here that you have x, you put 3 minus 2y in its place. So it looks like this. It used to be 3x, but rather than writing x, I'm going to write 3 minus 2y. And then here, 4, but rather than writing x, I'm going to write what x is equivalent to, which is 3 minus 2i. You guys see how I've taken the 3 minus 2y and I've shoved it into the spot where x used to be? That's called substitution. Now I have one equation and one variable. Now I can solve this thing. So this is what we've actually been doing for the last little while. How do I solve this thing? If you like my rope analogy, this is a tangled up rope. So untangle the rope. So what do? Expand it. 3 times 3 is 9, minus 6y plus y, that's 12, minus 8y, and minus 7. Is this quadratic? Any y squareds? Okay, so if it has y squareds, make one side equal to 0. But there isn't y squareds here, so how do you solve? Yeah, put all the y's on one side. Put all your numbers on the other side. So, I don't know. I'm going to add 8y to this side right here. That'll make that little bit go away. And I'm going to subtract 9 from both sides. And that'll make that bit go away. 6 plus 8 is 2, plus 1 more is 3y on that side. 12 minus 7 is 5. Minus 9 more is negative 4. 12 minus 7 is 5 minus 9. Yeah, negative 4. And then divide by 3. There, I solved for y. That makes sense? Mm-hmm. Here's the problem, we're not done. I said this is multivariable algebra. So we've now solved for what y is, so that would be like solving for distance. But we may also need to now solve for the time. Right? We need to find the other variable that we don't know. So the other variable is what x was. So, but we have what y is equal to. So often what we do now is, well, here's an equation that could solve for x. X was equal to 3 minus 2y. So I'm going to kind of substitute this number right here in for y. So 3 times minus 2 times minus 4 over 3. We're working our fractions here. What is negative 2 times negative 4 over 3? How do you multiply fractions? You guys remember? You have negative 2 and you're timesing by negative 4 over 3. So kind of pretend that it's 2 over 1. Take the top, multiply by the top, and the bottom by the bottom. Yeah? I'm going to recommend that decimals are usually not preferred because at some point you have to round a decimal. And if you want to stick with -1, it's a good skill to have. So even though fractions are not really that much fun, to be honest, actually, after next week, we're going to do a whole bunch of stuff that's based on fractions. So it's probably worth it to keep practicing with them. So that's not right. Would it make sense then that when you multiply these fractions that you have 8 over 3? How do you add fractions? Common denominators. You guys know that term? Do these guys have common denominators right now? What is the denominator of this 3 right here? Good. Okay, good. 1. Okay, so 1 has a 1, 1 has a 3. Hopefully this is something you guys have seen before then. If I times this guy by 3 over 3, that's like timesing by 1. Does that actually change the value? Hopefully no, it doesn't. So what does 3 over 1, it's almost like I'm upscaling it. This 3 over 1 can be written as 9 over 3. Does that make sense? 3 times 3 is 9, 3 times 1 is 3. So 9 over 3 and 8 over 3 gives a grand total of 17 over 3. So here's my two values. Y, nope, that was x. My bad. X was equal to 17 over 3, and y was equal to minus 4 over 3. That's what makes this more challenging. And you can probably see this is why, although -1 and -2 curriculums are very similar, this is taking it to a whole new level, right? I mean, we're still using similar skills, we're still solving, but I mean, this is way more challenging. So, is that something you guys kind of remember doing last year at all? Yeah. Okay, good. Because it should have been like a a short topic. It wasn't a big part of grade 10 curriculum, but it should have been something you did a little bit of. So, that's what my next slide's about. There's two main ways of solving. I default to substitution myself. I find it's the best method. It isn't the only method, but it does work. So here's what we did in words. Manipulate one equation such that a variable is isolated, then shove it into the other equation so that only one variable remains. People words, not math words. Shelby?
So then we would just have to solve, like, do we just pick one to do, or is there some that, like, we have to do substitution, some that we have to do?
You should be able to solve using either way, but depending on the equations you're given, sometimes elimination is a better choice. I default to substitution if I'm able to, but I do elimination if I recognize that substitution is not going to be useful. So, okay, well, elimination, I'll show you guys how to do that one in a second in case you've forgotten, but elimination involves manipulating both equations so that you can either add or subtract from each other, and you try to eliminate a variable. So, let's do some more examples here. Is this the one we just did?
Yeah.
Okay, so since we already just did that one, why don't I go to the slide where we do elimination then? Since that was the exact same one. Elimination involves manipulating the equations so that you can stack these things on top of each other and find a way to get rid of a variable.
Tasha, red young man, can you please come to the office? Tasha, please come to the office.
I might suggest that I want to eliminate y. But here's the problem. See how there's two y sitting over on this side right here? And there's only one y sitting on this side right here? I want to make it so that I have 2y in both of the equations. So here's a trick I can play. I could make this 6x, 2y, 8x, and minus 14. See how I've doubled everything? I showed a lot of you guys that trick in on your first assignment to get rid of decimals. You can just double the whole thing. So that's valid. I also want to manipulate this equation right here, though. I want to have the 2y that I just got over here. I want it on the same side of the equation. You see how the 2y is kind of on the wrong side? I'm just going to bring it to the other side. And so I could write this one as x plus 2y equals 3. So I'm just making some subtle changes to the equations, but the purpose is I want this one to be the same as each other. What I'm going to do is I'm going to subtract equations from each other. So I'm going to stack them on top of each other. It'll look like this. 6x plus 2y will equal 8x minus 14. And then right underneath it, I'm going to write x plus 2y will equal 3. And I'm going to take the two equations I just made and I'm going to stack them. Hopefully this is kind of familiar. Maybe not in this exact way, but okay. I'm now going to subtract equations from each other.
Excuse me.
What is 6x minus 1x? Perfect, okay. This next step is the whole point of the elimination. What is 2y minus 2y? Nothing. I have now gotten rid of y. This next one is kind of weird. What is 8x subtract nothing? 8x, yeah, we gotta leave 8x there. And what is minus 14 minus 3? Minus 17. That makes sense so far? We've now eliminated, hence the term elimination, we've eliminated y variables. So we're now back down to single variable math. So to solve this, is it quadratic? No, just get x by itself. So I'm going to minus 8x from both sides. That's minus 3x equals minus 17. Divide by minus 3, divide by minus 3. X equals 17 over 3. Isn't that what we got 2 slides ago? One of the nice things about doing it like this, perhaps, is that it actually gave us the fraction right off the top, though, right? So that's a little bit nicer. Here's the problem with elimination, though. I've only solved for x. I still technically need to solve for y. I mean, I know what y is because we did substitution, but I still should do it for elimination. So I got to find one of these two equations. Doesn't matter which one. And I want to try to get y by itself in one of these equations here. I'm going to suggest this guy right here. it just looks easier than the other one. So I'm just going to rewrite it as x plus 2y equals 3. It was x plus 2y equals 3, but now I know what x is. So 17 over 3 plus 2y equals 3. How do I solve for y? I think you should probably subtract the 17 over 3. Does that make sense? Like you should bring the 17 over 3 to the other side. So now you have 2y equals 3 minus 17 over 3. I know you guys have calculators. You probably know how to type this into your calculator to get an answer. I'm going to strongly recommend you got to practice your fractions because that's like the next part of our unit actually after this. So as much as it sucks, work on your fraction skills. So how do you subtract? Yeah, 3 over 1, and then give it common denominators. So I mean, you could write it over 1 and then times by 3 and 3. So 2y now equals 9 over 3 minus 17 over 3. 9 minus 17. Negative 8 over 3. That makes sense? How do I get rid of the 2? Perfect. So divide by 2. I might do this then. To divide by 2, I'm just going to put the 2 on the bottom of this fraction. I'm kind of like I'm bringing it from the top up here down to the bottom down there. So y equals negative 8 over 6. Because I can just make the 2 times 3. And then one last step, I can reduce this. So this should be negative 4 over 3. Which I think is what we had for y, isn't it? Y was negative 4 over 3. So far so good? Let's try some more examples then. We can solve quadratics with multiple variables. Similarly, it is possible that you could have one answer, you could have 2 answers, you could have no answers. And we've got to deal with this for x's and for y's. So here's where we're starting. Any suggestions? How can I solve this? Substitution, elimination?
How do we judge substitution?
I would probably say my rule of thumb is if it's easy to get one of the variables by itself, do substitution. If like it's not too difficult to like get either y or x by itself, try substitution. If that's not going to work, then try elimination. So, like for example, in this equation right here, can I get one of my variables by itself fairly easily? Which one? X or y? Is it possible to get x by itself? I guess. I mean, you could make it 13x equals y minus 2, and you could divide everything by 13. There, we have x by itself. That sucks. That makes sense? So I'm probably not going to want to do that. So I'll just erase that all. But it's actually pretty easy to get y by itself. 13x plus 2 equals y. Just bring in y to the other side. So based on this one, I'm going to choose substitution because I think that was probably pretty straightforward. So now using substitution, take the 13x plus 2 that we just got right here and shove it right there. Hence the term substitution. So now write it as 2x x plus 4 equals, oh wait, I should be writing y, equals 13x plus 2 plus 1. Which side? Oh, yes. Okay, but here's the difference, though. We still haven't untangled the rope. There's a bracket right here. Gotta foil it, which means I'm going to get 2x squared plus 8x equals 13x plus, what did I call that, 3? This is different. I don't want to just get x by itself now. Now we have to solve using a method of solving quadratics, which means get everything on one side. Does that make sense? And make it equal to 0. So this is going to be 2x squared minus 5x minus 3 equals 0. One thing you'll notice about where we're heading, math no longer can be done in like this much room on your page, probably. Like we're getting to the point where it may be like a full page, half page. Like it's going to take a lot of room to solve a question. Because like we're barely even started actually. How do I solve this? Any ideas? What'd you say? What are some of the methods we have for solving quadratics? You can factor. Let's say you can't factor though. Why don't we go to the quadratic formula? It will always work. So let's just default to that one. Even though you might have been able to factor, let's try the quadratic case. So it's negative b. So that's negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times negative 3 all over 2 times 2. By the way, something I noticed in some of your guys' work, make sure this fraction extends all the way. I know it's a little thing, but it makes a huge difference. This 5 right here is on the top of the fraction. I noticed some of you didn't have that on your assignments. Okay, negative 5 is just positive 5, I guess, right? Help me out with the discriminant. What is 25? Let's see. A double negative means you're going to add, right? So it's 25 plus 24? Is that a 49 under the square root sign? Has anyone tried that in their calculator yet? Negative 5 squared minus 4 times 2 times minus 3. Help me out, just make sure. Because that's 25. 4 times 2 is 8. 8 times 3 is 24. 25 and 24, it should be 49. You get 49? Okay. If you get an actual square rootable number, what does that mean? Yeah, it means you could have factored it. I mean, no big deal that you didn't. I mean, unless I specifically tell you to factor it, if you get an actual square rootable number, it just means you could have square rooted. So we should actually finish solving this then. Don't leave it like this if you can actually square root. This is 5 plus 7 over 4, or it's 5 minus 7 over 4. 7 because that's what 49 square roots do. So 5 and 7 is 12, divided by 4, 3. 5 minus 7, negative 2, divided by 4, negative a half. Does that make sense? Are we done? No. Welcome to Dash 1. We've just now solved for what x equals. I think it was x, right? Yeah, we just solved for what x equals. We have 2 answers for x. We now need to solve for what y equals.
So if we have 2 answers for x,
it's very likely that we have 2 answers for y. It's not a guarantee. It is actually possible you could have 2 answers for x and the same answer for y. That's actually possible. But we have to do this twice. So now that I have, like, say, this equation right here, 13x plus 2 equals y, I'm going to use that one. It was what, 13x plus 2 equals y? I'm going to use that one twice now. So I'm going to go 13 times 3 plus 2. So that would be 28. And 13 times minus 1/2 plus 2. Think about that one. I guess I should probably make that fractions. That's minus 13 over 2 plus 2. I could call that minus 13 over 2 plus 4 over 2. I'm doubling that guy. So that makes it minus 9 over 2. Did I lose you guys there? Okay. So I had I had my equation 13x plus 2 equals y, and I'm plugging in minus a half. So to try to figure this out, 13 times minus a half, I just made it minus 13 over 2. Then I'm adding 2, so it's like 2 over 1. So then I'm timesing this by 2 and by 2 to get common denominators. So 2 times 2 would give you 4 over 2. So then minus 13 plus 4 is minus 9. I'm finally done. Here's my answers. X can be 3 or minus a half. And it looks like Y can be 28 and minus 9 over 2. That was fun. I've said this before, especially for Dash 1 math. It's an accumulation of skills that you've learned over not just this year, but like a lifetime of math. Fractions don't just magically go away because you stop learning them in grade 8. And so I'm going to recommend, like, if you truly want to be good, I mean, not just pass, but like if this is a skill because you know you're going to use Dash 1 math going forward, it sucks, but you got to get comfortable using fractions. And you got to get comfortable using square roots. It's not easy, but that's kind of the expectation going forward. Does that make sense? So, I mean, if you wanted to use your calculator and type all this mess in your calculator, it's going to tell you it's negative 4.5. And you can probably use a button on your calculator, that fraction button. And the fraction button will make it negative 9 over 2. But then you're depriving yourself of the skills you need going forward. Does that make sense? Okay, let's try another one. This guy here. You guys want to do a break now? How much more do I have? I don't remember. Yeah, I got a lot. How about we do one more? I'll try to go a little bit faster, and then we'll take a break, because I still got a few left. Is that okay? Can you do one more example? Okay. I'm going to suggest something different on this guy. Let's do elimination on this one. I can see a reason why elimination might work really nicely. Although I can get y by itself, another suggestion is, you know how last time I wanted to get the exact same amount of y's on both sides? It wouldn't be hard to. What if I made this 10x minus 2y and, not 10, 20. Yeah, let's do that again. 10x minus 2y and 20. Does that make sense how I just doubled that one equation? Right in the next step, I'm just going to drop that next equation right underneath it. X squared plus x minus 2y equals 0. What's going to eliminate? Yeah, those negative 2i's will eliminate. I have to subtract, though. So I'm going to put a subtract sign out here. Make sure you're really careful here. You have nothing up top here, and you're subtracting x squared. Negative x squared. You have 10x, and you're subtracting x. You have 2x minus, or 2y minus 2y. It's gone. Yeah, I mean, that's the whole point, right? And you have 20 minus 0. 20. That's an equal sign, by the way. How do you solve this? It's quadratic. Make one side equal to 0. I have a personal preference myself. I always like my x squared term to be positive. So although it's easier to bring 20 that way, I'm actually going to bring myself. I prefer bringing these guys that way. I just find it easier myself. So 0 now equals positive x squared, negative 9x, and 20. And this, although you can use the quadratic formula, you can factor that, right? Add to 9 times to 20. 4 and 5, yeah, some combination of 4 and 5. So x minus 4 will do it, and x minus 5. So what does x equal? Oh, like positive 4 and positive 5, I guess you just said that. I'm halfway done. What else do I got to do then? I have to solve for whatever y is equal to. It doesn't matter which equation you use. It should work out the same either way. I don't know, this one here is probably easier. Just rewrite it down here. It was what, 5x minus y equals 10? So I'll do it twice. I'll do 5 times 4 minus y equals 10. And I'll also do 5 times 5 minus y equals 10. So let me know if I lose you. I'm just going to go a little faster because it's just arithmetic here. That's 20 minus y equals 10. So y must equal, okay, be really careful here. If I subtract 20, that would give me negative 10, and they're both negative, so positive 10. 20 minus what equals 10? 20 minus 10 equals 10. Yeah.
Up at the top of your screen where it's the x minus 4 and x minus 5.
Yeah.
It says, the next sentence says x equals 4, 5.
Yeah.
Does it have to be negative or positive?
It should be positives, because if you want this binomial here to equal 0, you better use a positive 4. Because then positive 4 minus 4 would give you 0. And then 0 times anything would give you that 0 right there. So whatever the factor is, the answer is the opposite of that.
Can you explain why it's the positive 10 on one side? Because if you bring like the 20 over the other side, negative 10, so say y equals negative 10.
So then if negative y equals negative 10, wouldn't positive y equal positive 10?
Oh, okay.
Does that logic make sense?
Yeah.
Okay. I'm kind of just doing this in my head. 25 minus what number gives me 10? 15. So how many answers are there? 4. X is 4 and 5. Y is 10 and 15. There's all our answers. It's gross.
Wait, so we didn't even use that other equation?
I could have used the other equation. I can test it real quick if you want. Here. 4 squared plus 4 minus 2y equals 0. So like I'm plugging 4 into this equation up here. So that would be 16 plus 4 equals 2y. So that's 20 equals 2y divided by 2 divided by 2. Yeah, y is 10. So like when you plug your numbers in, you should be able to plug them into either equation. I just didn't choose to use this equation here because I thought this one here was nicer. I did use it though because I used it to stack the two equations on top of each other.
Oh, yeah.
So it was used at some point. We didn't just omit it the entire question. Does that make sense?
Yeah.
Okay, I'll go take a break. You definitely need one. We'll do some more examples when you get back.
Scroll down so I can see that.
For sure. You want both there? Okay. Really?
This was about the hardness of the other one. This is about where we're at right now.
Yeah. Yeah.
Huh? Is there a problem with that?
Yeah.
Don't worry, Shelby, you'll fail.
I'm not gonna say.
Alright. Guys, how about this next question here? How about we skip it for now? And I'll have you guys try it yourselves after maybe one more example. Is that okay? I'd like you to try one yourselves, but I want to try one of the ones that are just a little bit more tricky first, and then maybe go back to that one. So why don't we do this one as a group, and then after that, why don't you guys go back and do the one we skipped? Because if you're looking at this one, that's probably your first thought, holy crap, why am I in -1 math? Anyone have that thought? Yeah.
Totally think
Oh.
it.
Okay.
Yeah.
Alright. That's why you're here. I'll say this a lot. If you knew how to do this, I wouldn't have a job. If you knew how to do this already, I wouldn't have a job. So, that's why we're here. Okay, first suggestion then. We're kind of combining a whole bunch of skills that I've shown you over the last little while together. This is kind of ugly. It's like untying the rope a little bit. Let's factor, or not factor, let's FOIL. let's get rid of the ugliness. So make this 3x squared minus 3x minus y equals 2.
Wouldn't it just be minus that?
Thank you. Good catch.
What? Wait, what?
That's 3x squared minus x minus y equals 2. I had 3x. Thank you, Jamie. Good catch. See? I make mistakes.
Good job, Jamie Brown.
I'm a person.
Everybody makes mistakes. Everybody has those things.
Okay. Okay, we can also FOIL the second thing too. So that's 4 minus 4x if I don't screw up.
I understand what's going on.
Pay attention.
I'm just FOILing out the brackets.
Okay.
This is easy for you, Shelby.
I know.
Okay.
I look at my paper.
So we have to make a choice now. We have to do either elimination or substitution. And I mean, I can't give you a dead rule that'll say always do this or always do this. But I can give you some suggestions. Okay? If it's easy to get an x or y by itself, maybe do substitution, if that seems fairly easy to do. Or if you can see a way to somehow stack things on top of each other fairly simply, elimination might work well. To be honest, in this case here, I actually see a trick I can play to make it so that I could do elimination fairly simply. See how I have a negative y right here? And I have a negative y right here? I'm going to stack them on top of each other.
Well, actually, even with like the equals sign.
It should still work. So watch this. I'll rewrite it all out. So I have a 3x squared and a negative x and a negative y and it equals 2. So that's this equation right here.
Yes.
This next equation here, when I stack it on top of each other, I'm going to make sure that I stack like terms together though. So you see how this guy's got a 6x squared? I'm going to put the 6x squared right there. There is no x term on this side here, so that's fine. I'm just going to put the minus y way over there. And then the 4 should probably go underneath the 2. And I'm just going to put the minus 4x off to the side. I'm just kind of stretching it out a bit. But elimination looks like it should work. Just be really careful when you subtract. So what is 3 subtract 6? Negative 3. The next term seems kind of dumb, but what is negative x subtract nothing? Negative x, yeah, it doesn't change. Your minus y subtract your minus y?
2y.
Nope. Minus y subtract minus y.
Nothing.
Yeah, that's the whole point.
Whole, like, double negative thing.
So that should go away. 2 minus 4 is negative 2.
I promise I'm smart.
Hey, you know what? I'm glad you're saying it, though. Like, I appreciate that you're trying. It's better than, like, a...
She was so calm.
Well, no, here's what I mean. I appreciate that over, like, no one saying anything. If you guys don't say anything, boy, it's boring.
Supposed to be the talk.
Sorry.
You're supposed to say yes. Okay.
I didn't know if they could just.
Okay, the last one I want to point out here. You have nothing, and you're subtracting minus 4. Good. Yeah. Be brave. I'm not going to make fun of you. Well, like, I don't think I'm making fun of you. It is positive 4.
Yes.
Oh.
Yeah.
Well, then don't make fun of each other. It's okay to make mistakes. All right.
Yeah, guys.
What do we have here, then? We have a quadratic. How do you solve quadratics?
Put everything on one side.
Okay, now again, you can put anything on any side you want, but my personal preference, I want positive x squareds. So I'm bringing everything this way. That's just my default. But that's not the only way of solving. So you would then have the 0 on this side. You'd have positive 3x squared. You'd have 5x. And you still have minus 2. One thing you're going to learn in this unit here is that we started at the bottom and learned how to solve linear things and then quadratic things. We're often going to get to the same point here now where I'm going to say, solve this. And you have 2 options. Factor it if you can, or use the quadratic formula. Shelby.
Since there is there's like a variable or like a number in front of like the x squared.
Yeah.
Can you just like go right into the quadratic formula so you don't have to put it there?
Sure, if you want to, you could.
Okay.
But let's do it the other way this time. Just for practice. You could use the quadratic formula. You're looking for numbers that add to give 5. You're looking for numbers that multiply to give that 3 times the minus 2, so minus 6. Negative 1 and 6? No. Negative 6 and plus 1. Is that what you said? No. No. Plus 6, negative 1. Is that what you said? Okay, good. I'm wrong then. Plus 6, negative 1. So I'm factoring. We could use the quadratic formula, but know how to factor too. Like, don't just throw that skill out the window and be like, nah, I don't need that skill. So break the middle term up into plus 6x minus 1x minus 2. Factor out the 3x, leaves you with x plus 2. Let me know if I lose you. I'm just going to keep going here. There. I factored.
No, it's not, Devin. Who phones you?
It's pretty much the same skills going forward, Devin, just difficult questions, that's all. So we can work on this later if you want.
Yeah.
Is everybody able to factor down to that point?
Yes.
Last step then, we need to solve. X is a third, and x is negative 2. Are we done?
No.
Ah, don't you love Dash 1 math right now? You're just like, yeah, I'm so glad I stuck around. Ooh. Hey, if you want me to teach you, I'll teach you. Alright, last step. Plug this back into an equation and solve for y. I don't care which equation. They both should work. They both suck. It's not like one of them's better than the other. So, you know what? I like this one here better myself, just because I guess both x's are on the same side. I don't know. It should make a difference. So, 3x squared minus x minus y equals 2. 3x squared minus x minus y equals 2. Okay. I'm going to save the 1 over third. No, let's do the 1 over third first. It's hard.
Yay.
Yay. Okay, let's plug in 1/3. 1/3 minus 1/3 minus y equals 2.
Do you have to do like the 1/3 to the power of 2 before you times it by 3?
Yeah, bed mass comes first.
Okay.
So let's talk through that. 1/3 times 1/3 is 1
Marley
over
Duncan,
9.
can you please call 100? Marley
Prove it to
Duncan,
you.
please call
1/3
100.
times 1/3 is 1 over 9. Makes sense? So what this is right here is this is really 3 times 1 over 9 minus 1/3. I'm going to mess around with this a little bit. Can I add y to the other side and then subtract 2 all in one step? Does that make sense? I'm just basically flipping these guys as sides here. Okay, common denominators time. 3 times 1 over 9 is 3 over 9. Right? Because this is like 3 over 1 times 1 over 9. So it's 3 over 9. But 3 over 9 reduces back to 1/3. That makes sense?
Y equals minus 2.
So really this is 1/3 minus 1/3 minus 2 equals y? Yeah. You don't. Only for adding and subtracting.
So y just equals negative 2.
Yeah, those kind of go away. There we go. That actually wasn't that bad. Like I said, though, you can use your calculator. Don't get me wrong. Like, your calculator will work, but if you really want to develop the skills you need going forward, I wouldn't. I know. But this time was with negative 2, though, so it's not as bad, right? Negative 2 is not a fraction. So there's an answer, there's an answer, there's an answer. Let's do it all again with negative 2. So 3 negative 2 squared minus negative 2 minus y equals 2.
Can we just add 2?
Yes.
Oh, for this one right here? Sure, yeah. Yeah. So, I don't know how you want to do this. That's 3 times 4 plus 2. Can I do the same little trick and bring y to the other side and kind of flip those around? So minus 2 equals y. 2 minus 2, that's going to kind of cancel. Ta-da!
Why mean, that wasn't that difficult.
Not that bad. Don't get me wrong, it could be horrible. Like, fractions are not fun, but I don't know. I can't promise you fun.
Yes.
Okay, I think I probably covered enough. I mean, these are the skills you need. The question is, can you apply and extrapolate those skills to challenging problems? Right? That's kind of the point of math. I've said this before. Are you going to use this at some point in your life? No. No, never. I mean, no one's going to come up to you on the street and say, solve this for me. But that's not why we're doing this. We're doing it because we're trying to develop the skills you'll need to be able to be good problem solvers. Because problem solving is the more important skill. But if you want to do it at a -1 level, I'm going to make it, to be honest, I try to make it as hard as I think you guys can do. So I'm going to challenge you. Shelby.
Is this all we need to know for assignment, or is there more things?
There's more for the assignment. The assignment isn't due till next week, Thursday, though. But on the assignment, we still got to talk about 3 topics on radicals. So this, by the way, not on your quiz. So if you're kind of freaking out going, there's a quiz on Wednesday, this is not on your quiz. So why don't you guys try one of the other 2 examples I didn't do then? Why don't I give you guys some time to try it without me doing it first? And then I'll give you some answers in a little while. I think I'll stop the video here, though.